a very good evening to you one and all. So here in this video today we are going to see two important chapters, circles and also areas related to circles. So I have given all the concepts provided with all the important numericals that are important for the exam point of view. And if you guys have any doubts in this chapter or in the earlier uploaded chapters, I have given my WhatsApp number so that you guys can book a class and then we can see all the concepts and examples. So with this, we go to the session and all the very best guys. Thank you. Hello guys, today we are going to see two chapters, circles and areas related to circles. Both of them are very simple chapters. Now let's go into the session right now. So in circles, as per your textbook, you have some topics, that is introduction, tangent to a circle, number of tangents from a point of the circle. So those topics are there. And in areas related to circles, you have just one topic, that is area of sector and segment of a circle. So now let us see the conceptual notes. So in this conceptual notes here you can see that OP is nothing but the radius of the circle and AB is nothing but a tangent, because a tangent is a circle which touches the circle at only one point. Here it touches the circle at P. So AB is a tangent and OP is nothing but the radius, as I told you. So there is one theorem, that is a tangent is always perpendicular to the radius at the point of contact. So this is a theorem. Tangent AB is perpendicular to the radius OP at the point of contact P. Point of contact means where the tangent and the radii actually meets. That is a point of intersection of the tangent and the radii. Tangent and radii intersects at P. So P is nothing but the point of contact. So the first theorem in your circles is tangent is always perpendicular to the radius at the point of contact. Now let us see the next theorem. The second theorem in your circle is tangents drawn from an external point to a circle are equal in length. So P is a point outside the circle and PA is a tangent, PB is another tangent, OA and OB are nothing but the radii. So PA and PB are tangents, OA and OB are nothing but the radii. So the second theorem is nothing but PA is equal to PB. You have to prove that PA is equal to PB. So length of the tangents drawn from an external point to a circle are equal in length. Okay, this is the concept. Okay, next is there are some interesting points. This may be asked in this points may be asked as questions to prove. So tangents drawn at the ends of a diameter of a circle are parallel, and parallelogram circumscribing a circle is always a rhombus. So there's one more important property. If two circles are concentric means which has the same center. OS is nothing but the radii of the smaller circle and OQ and OP are nothing but the radii of the bigger circle. Now OS I am assuming it as A and OQ and OP I am assuming it as B, because both of them are equal, because radii of the same circle are equal in length. So if this is the case, then PQ, that is the length of the chord of the larger circle. PQ here is a chord. So the length of the chord of the larger circle which touches the smaller circle. So here it touches your smaller circle. So the length of the chord of the larger circle, that is PQ, which touches your smaller circle, it is nothing but, there is a formula. This is a formula 2 root of b square minus a square. Of course, this formula can be derived by applying Pythagoras theorem and then by taking twice of one of the radii, that is either PS or SQ. So PS or SQ will be equal to root of b square minus a square as per Pythagoras theorem, and then you just have to double it to find the value of PQ. So it's very simple thing. So these are some of the important properties. Now let us see the important formulas related to areas to circles. Areas related to circles, first thing, all these are formulas. So I have just given you all the formulas. Circumference of a circle 2 pi r, perimeter of a circle is pi r plus 2r, r is common here. So if you take r as common, you will get pi r into pi plus 2, and distance traveled by a wheel in one revolution, rotational motion. Distance traveled by a wheel in one revolution, it is nothing but the circumference of the wheel. and number of rotations in 1 minute, that is equal to distance moved in 1 minute whole divided by circumference. So this third and fourth formula you may be very rarely applying. Not many questions will be asked. So rarely the questions will be asked based on the third formula or the fourth formula. Fifth and sixth are already the basic. Area of a circle is pi r square. Area of a semicircle is half pi r square. Area of a ring, that is a difference in the areas of two circles. That is pi into capital R square minus small r square. So the difference in areas of two circles, that is nothing but the area of a ring. And next is length of an arc, which is theta by 360 into 2 pi r. Perimeter of a sector is theta by 360 into 2 pi r plus 2r. See, this is nothing but, this is theta by 360 into 2 pi r is already length of an arc. So it is equal to L plus 2r. If you keep this as L, so perimeter of a sector will become L plus 2r. And area of a sector, normally sector means they refer to minor sector. Major sector means specifically they will be giving. So area of a sector minus sector is equal to theta by 360 into pi r square. And area of major sector is, either you can do 1 minus theta by 360 into pi r square, or by taking the LCM you can do 360 minus theta whole divided by 360 into pi r square. Any case if you do, you get the correct answer. So it is nothing but 360 minus theta whole divided by 360 into pi r square. Now let us look at the next concept. Area of a sector, if length is given, if the length L is given, so then it is nothing but half LR. And area of minor segment, which is nothing but pi theta by 360 minus sin theta whole divided by 2 into r square. And area of major segment is nothing but pi r square minus this one. Pi r square minus area of the minor segment will give you area of major segment. So pi r square minus pi theta by 360 minus sin theta by 2 into r square. And area of quadrant of a circle. Quadrant means we have seen in the basics that a circle is divided into 4 parts. Those are nothing but quadrants. That is complete angle makes 360 degrees. So 360 divided by 4 is 90. So since it is circle is made into 4 parts, so area of one quadrant of a circle is nothing but 1 by 4 pi r square. After that, I just have drawn this diagram to make you understand what is a sector. Here OAPB, this region, you can see OAPB together is called a minor sector. Other than that, OABQ, this entire region OABQ is nothing but the major sector. Here you can see the shaded portion is nothing but minor segment, which is APB, and the other areas, that is AQB, is nothing but the major segment. So just to make you aware of what is minor sector and major sector and what is minor segment and major segment, I have illustrated you with the help of a diagram. Now after this comes the questions. This 10th chapter is all about circles and the 11th chapter is all about areas related to circles. I have given you the questions. See, both these questions are taken from the new edition of the textbook. So if you guys are having old edition, kindly refer to the new edition. The books will be there in online or in shops, so you can refer to it and then you can study. And if you guys have any doubts, not only in circles and areas related to circles, but in any of the chapters that we are uploaded already or in the chapters about to come, you can feel free to book a class. I have already given my WhatsApp number, so you can contact me at any time. So with this, we come to the conclusion of this class, and all the very best, guys. Thank you.
Fall apart.